Skill 5, let's get this done. So, there are 7 types of organic chemical reactions that you have to know that are associated with organic chemistry. So how are you going to remember all 7 of these? Well, you're going to basically remember this. PS spaces. So in this short unit, you're going to learn what all of these different letters stand for and ultimately how they're created. Okay. So this P stands for polymerization. And for those that are not familiar, polymer means many pieces put together. So when we're talking about polymerization, we're talking about something that may look like this. A number of, let's say, these types of alkenes are going to ultimately create something that has a whole bunch of carbons now as single bonds. Okay. So instead of having just the pieces, now these guys are connected together X amount of times. Okay. This is found throughout nature as well as throughout materials chemistry and science. So natural polymers that we know about are cellulose. This makes up cell walls. Other natural polymers would be starch, which are chains of glucose molecules. Proteins, those building blocks are made of amino acids. Glycogen, that's how we store our sugar in our body. Synthetic things, we call these synthetic polymers like nylon or rayon. Mostly plastic, so like polyethylene, anything. And that's how it's made. So you have a number of different particles that are all by themselves, so I'm just going to call these building blocks. And then this is your long chain. Second type of organic chemical reaction is substitution. Just as the name implies, you're going to take something out and substitute it. So you might see something like this. We have, what are we going to call that? We're going to call that ethane. And let's, I don't know, let's do chlorine gas. Now chlorine exists as a diatomic molecule. And just like any substitution, we're now going to take something out and put something in. So let's take out this one. Okay. So I have an H, C, C, H, and at my substitution part, I have my Cl. But that H has to go somewhere, so the H now matches up with the remainder Cl. So notice we went from a saturated carbon, okay, to now something that has a functional group. Okay, so just one way to look at it a little bit differently. So there's your PS. Let's start with the faces. So fun one. F stands for fermentation.
Natalie Amadon, you're being picked up. Natalie Amadon, you're being picked up.
This is where a natural process exists where we take sugar and we break it down into an alcohol and carbon dioxide. Okay. If we wanted to balance this, you can do that on your own. But I will tell you, for every one glucose molecule, which is this, it makes 2. What would we call that? And of course the bubbles, which are carbon dioxide. Okay. So this is our beer and wine process. A, addition. Just like it says, you're going to add one or more molecules together. Okay. And when you add them together, you're ultimately creating something that was unsaturated into something that is saturated. So we're now going to something else. Okay. Addition can be very similar to substitution in that double bonds can break, but mainly in addition you're going to see something added on, but something totally added on. So if I were to put chlorine on all the time, both of those chlorine are going to be added on to whatever was made, and again break those bonds, and ultimately creating some kind of hydrogen gas. Speaking of gas, combustion. By now you should know that combustion is the burning, most of the time, of hydrocarbons, hence it's an organic reaction. You can have complete combustion, which is basically taking, let's say, go with propane, which is used for propane tanks. We're going to add oxygen to it, and it's ultimately going to create CO2 and H2O. This is not balanced. If you want to balance it, this is what you should get. Okay. And we know for the most part that we do have incomplete combustion, meaning that all the oxygen present, there's not enough to actually have everything go down to just carbon dioxide and just water. So in some cases, incomplete combustion can actually create something called carbon monoxide. That's your deadly killer. You should have carbon monoxide detectors in your house. Okay, we're getting there. We're getting there. Esterification. This one you have to know. Like, you have to know this because there is always, always, always a question about making an ester. So here's how it works. You take an organic acid, add alcohol, and you're creating that ester that you want, and water. Okay. Memorize. Memorize, memorize. And last but not least, if you ever wanted to make soap, it's called saponification. And if we have time, we can make it. This is where we take these esters, put a base in it, and ultimately it creates an alcohol, which you don't want to drink, and the soap that's used to wash your body. So that's the end for me. I will leave this up to you. Page 13 is basically a summary of the 5 major types of chemical reactions and 7 organic ones. If you complete this and hand it in the day that you have your organic test, and I will not say anything about this extra credit, this is how I will know, hopefully, that you have watched this video on your own. If you hand this in, you will get 5 points on your organic test. That is the end of organic chemistry.